welcome to another edition of Math is Still Math. Today we're going to be talking about division. For some reason it's always the most hated of the four primary disciplines. Division or skills. Division is what we're going to be doing today. So you fifth graders out there, you gotta learn to divide. And that'll depend a lot on your multiplication skills, your ability to estimate. But before we get started, we've got to start talking about some vocabulary. So let's just go over some terms I'm going to be using a lot in this video. My first term is going to be factor. A factor is any number or numbers that can be used to multiply to find a product. Now wait a minute. Mr. Matthews, you just said we were talking about division. Why is your first term a multiplication word? Well, guys, I hate to break it to you, but division and multiplication are the same thing. That's right. I said it. Multiplication and division are the same thing. Now, I don't want to get too advanced, but let me just go ahead and break it down for you. 10 divided by 2 is equal to 5. I think we could all agree that is true. Guess what? 10 times 1/2 is also 5. So, as much as we like to think that division and multiplication are different, in a lot of ways, they're just the same. So, when I use the word factor, I can use it when I'm talking about division or multiplication. But an example of factors would be right here in this problem. So 2 and 5 are factors of 10. 2 and 5 are factors of 10 because 2 times 5 is 10. You just flip the sentence around and all of a sudden you got factors in a division problem. Many of you are used to seeing division in this format, where you've got numbers in and above this weird bracket. I'm pretty sure, if I've got my vocabulary right, that this division bar originated as a parentheses and a vinculum, I think was the word. Essentially, it separates 3 vocabulary terms, and here they are. So the 10 is the number we call the dividend. Dividend is the value that's actually being split up or divided. 2 is the divisor. This is how many times we want to split it up. And then 5 is called the quotient, otherwise usually commonly called the answer. The quotient is the value that would tell you how many are in each group when dividing. Now back to my term factor. The factors here are the quotient and the divisor. Because if you were to multiply those together, you'd get the dividend. We can prove it. So 2 and 5 are the factors of 10 because if you were to test it, and you should test your work, because 5 times 2 is equal to 10, that proves that our answer is correct. So just to recap the vocabulary I'll be using a lot today. The word factor. Those are the 2 numbers that can be multiplied to reach another value or product. When we're dividing, the number that's being divided is the dividend. The amount or the number of groups that I'm dividing that dividend up into is called the divisor. And the answer to your problem, which is the other factor, is going to be the quotient. So now that we've got some basic vocabulary worked out, let's talk about how we're actually going to do the division on our paper, because there's a few different ways to do this. Oh, I forgot. There is one more term that is probably going to show up here in the next few minutes, and that is a remainder. So, and if you're unfamiliar with the way this bracket looks, don't worry about that for now. Just understand that sometimes when we do division, we're going to have a leftover. And that leftover is often called a remainder. For you more advanced learners, we can write those leftovers as fractions like this. So if you have the answer of 61 with a remainder of 2 and your divisor was a 3, then really your answer is 61 and 2/3. But I think that should cover vocab. If we need to add more in later, we'll do that. Let's talk about some strategies and how to solve some actual problems. Okay, so I just Googled the standard that I linked in the description, and I found a worksheet with this problem. So it's asking me to find out how many times 30 will go into 7,230. Now, for a lot of you parents out there, this is going to be the algorithm for how you solve it. So let's just go ahead and solve it in a traditional fashion. Now, I will say this. If you solve division problems in this manner, you have very high-level estimation skills that some of our younger learners don't have or have not polished up yet. And that's why sometimes it can be very frustrating to try and teach division this way to a new learner. Well, let's just go ahead and solve the problem this way. So I'm going to ask myself, can 30 go into 7? No, 30 doesn't fit into 7. Does 30 go into 72? Yeah. And if I count by 30s, 30, 60, 90 only goes in twice. So since 30 goes into 72 twice, I'm going to put a 2 right here. Now I do some multiplication. 2 times 30 is 60. And I subtract. 2 minus 0 is 2. 7 minus 6 is 1. Now, I check myself, 12. As long as 12 is less than the divisor, less than 30, I'm fine. I can continue. I'm going to bring down a 3 and ask myself the same question. How many times is 30 go into 123? And this is where our estimation skills have to come in. Well, 30, 60, 90, 120, 150 is 2. Okay. So I know that if I multiplied 4 times 30, I'll get 120. And I subtract. 3 minus 0 is 3. 2 minus 2 and 1 minus 1 are nothing. So 3 is less than 30. I'm still good. Nice and organized. You want to keep things in columns, nice and smooth. So 30 goes into 30 one time. 1 times 30 is 30, and my remainder is 0. So the answer to this problem, the quotient, is 241. 30 goes into 7,230, exactly 241 times. However, let's say you don't have those estimation skills in place. Let's just say you don't have a way to picture how many times 30 goes into 123 without some sort of assistance. Well, you're going to need a strategy to solve this problem. So here's a way that can work for some of our younger students. I'm going to assume here that you've played a game of hangman at some point in your life, so I don't have to explain the similarity between this bracket and what a hangman board looks like on your computer. But if you are not comfortable estimating, how many times 30 goes into 72 or how many times 30 goes into 123, then maybe you are comfortable doing some multiplication. Remember, I told you the multiplication and division are basically the same thing. Well, give me a number you can multiply 30 by. For instance, maybe you can multiply 30 times 100. What's 30 times 100? Well, 3 times 1 is 3, and I'd have 3 zeros, so that would be 3,000. So 30 times 100 is 3,000, and I can subtract. So even with 130s, I still have 4,230 to go. So I'm going to multiply by 100 again. Notice where I'm placing my factors. 30 times 100 is going to go right here in my bracket. So that'd be another 3,000. Subtract that off the top. Okay. So I still have to divide 1,230 by 30. So let's pick a number that I can multiply by. Now I can't multiply by 100 again, because if I multiply by 100, I'm going to be trying to take away 3,000. That's not going to work. So 30 times... What's 30 times 10? That'd be 300. We'll take that off. 0 minus 0 is 0. 3 minus 0 is 3. 12 minus 3. And we could borrow. If you want to do the borrowing, you would say, we'll take away from that, put it over here. So 12 minus 3 is going to be 9. So I've still got 930 to go. Okay, well, again, now, the better you are at estimating, the faster this whole thing will go. So you have to work on your estimation skills. Bring this bar on down. Okay, so 30 into 930. Well, 30 goes into 900. If we were to multiply by 30, 30 times 30, that'd be 900. 30 times 30 is 900. So we take away, and all we have left is 30. So 1 times 30 is 30. We have 0 remainder. Okay, so now here's where we get my answer. I have to add up all these factors. So 100 plus 100 plus 10 plus 30 plus 1, that'd be 100, 200, 210, 240, 241. We just add those together. So there's 2 successful methods of dividing 7,230 by 30 and getting an answer of 241. The reason the traditional method became the overwhelming popular way to do this on paper is simply because it takes up less room. It's very compact, and once you get the hang of it, it goes very quickly. However, it requires the highest level of estimation skills of everything I've done so far. The hangman method is a scaffolded way of helping a beginning learner do division in chunks. Like, I'm building up to 7,230 in blocks that have a factor of 30. So if I did 100 blocks, or 10 blocks, or 30 blocks, or just a single block, we can add all that up to reach our quotient. That's the answer to a division block. So, depending on your level of comfort with estimating, you can choose either method and do it well. Let's try another problem. Okay, well, here's another problem of that exact same worksheet. I just Googled and found it for extra practice. And I'll solve it both ways. I'm going to tell you now, this one's going to have a remainder. So, 16 into 4. Now, this will be the traditional method where I'm just a very, very good estimator. So, 16 into 49. I think that's going to go 2 or 3 times. 16 times 2 would be 32. 16 times 3 would be 30. 18, 48. Yes, we're looking at 3 times. 3 times 6 is 18. 3 times 1 is 3 plus 1 is 4, so it's 48. Okay. 9 minus 8 is 1. 4 minus 4 is nothing. So then I bring down the 3. 16 and 13, it won't go. So 0 times 16 is 0. Everything's still fine, because 13 is less than 16. 16 into 132. I'm a good estimator. I'm still going to have to guess on this one, so I'm just going to check something. So 16, I bet it's going to be, well, 16 is close to 20. That'd be 6 times. So let's try 16 times 6. See what happens. 6 times 6 is 36. 6 times 1 is 6 plus 1 is, that'd be 96. Ooh, not even close. 16 times, let's try 8. 8 times 6 is 48. 8 times 1 is 8 plus 4. Ooh, that's close. 8 times 6 is 48. 8 times 1 is 4. Yeah, it's not going to get any better than that. So I would say 8 times 16 is 128. Running into my scrap work. I have to borrow. 12 minus 8 is, so there's a remainder of 4. So that would be a remainder of 4 16ths. By the way, that's the 4 that's the remainder above the divisor, which is 16. That's where the fraction comes in. So it's 308 with 4 left over, which means, yeah, this is the remainder down here. So that'd be 308 and 4 16ths. And for those of you that really have to simplify your fractions, that'd be 308, 4 and 16, both divided by 4. There's your absolute best answer, because each of these can be simplified. But that's for another lesson. Let's take a look at how a student using Hangman method might solve this one. So I'm going to bring my bar down and ask myself, well, what can I multiply? What can I multiply 16 by? What is something I know I can do? Well, you might say to yourself, well, the only thing I know how to multiply by is 10, because 10 times 16 would be 116. Right? Yeah. Okay. Well, 2 minus 0 is 2. 3 minus 6, you can't do it, so I'm going to borrow. 13 minus 6 I can do is 7. 8 minus 1 is 7. And I still got 4,000. Okay, we're going to have to multiply by something bigger, because if we do tens all the way down, we're going to need a lot of paper. My paper's not long enough to handle all that. So, what if I multiplied by 100? That'd be 1,600. That should speed it up. So that'd be 271. Now let's do 100 again. Do 1,600. 2, 7, 1 minus 6, I'm going to have to borrow. 11 minus 6 is 5. 2 minus 1 is 1. So I'm 2. Always stop. When you start going fast, you might want to pause yourself and just check you didn't make a silly mistake. 2 minus 0 is 2. 7 minus 0 is 7. 11 minus 6 is 5. 2 minus 1 is definitely 1. Okay. Can I do another 100? No, I can't, because that'd be more than this. Alright, so I'm going to try 90 times 16 and see how close that gets me to 1,572. So 0 times 6, 0 times 16 is nothing, so I put in the placeholder to make sure my place values are all right. 9 times 6 is 54. 9 times 1 is 9, plus 5 is 14, so 1,440. Okay. Let me scoot that up so I'm actually on camera. So 1,400. So if I did 90 times 16, I get 1,440. Okay. So I can do that. So 2 minus 0 is 2. 7 minus 4 is 3. 5 minus 4 is 1. And that's it. Okay. So I've got 132 left to split up. And again, my estimation skills, I don't usually multiply by 16. So I guess I can multiply by something smaller, like 5. So what's 16 times 5? 5 times 6 is 30. 5 times 1 is 5, plus 3 is 8. 80? 2 minus 0 is 2. 3 minus 8. Oh, well, it's going to be 13 minus 8. So we have 52 left to go. So I won't be able to do 5 anymore. So maybe I do 16 times 3. 3 times 6 is 18. 3 times 1 is 3 plus 1 is 4. 48. Ooh, that's really close. So 3 times 16 is 48. So I do the borrow. 12 minus 8 is 4. And that's too small for me to split up anymore by 16s. So now I have to add up all of these. So 10, 110, 210, 300, 305, 308. And I have 4 left over. And my divisor was a 16. So that would be 4 16ths. That looks familiar, doesn't it? Yeah. So the hangman method is completely legitimate. It works every time. And the beautiful thing about the hangman method is that you could have done things completely differently and ended up with the same answer, because you might have multiplied by the hundreds first, or use some other factor that I didn't use. Maybe you multiply by 50s, or who knows what. It works. So even though both ways are successful, if you want to do it the faster, more compact way, like the traditional algorithm, the way that most of the parents and grandparents do their division, you've got to study up on your ability to estimate how many times is this going to this. You have to be good at rounding. And then even then, you might have to go out on the side of your paper and do some checking just to make sure that the numbers are going to line up. But these are the two ways that I advocate learning to do division on paper. I hope that this video has been instructive, and I hope it helps you find your way to do your division on your own paper. Leave comments in the description below if you have any other questions or want another tutorial on a different way to do division. Until next time, I'm Mr. Matthews. Please remember, math is still math.